Now over here when we study input from keyboard, we say in stated register we have the bit 15, stated register 15 is the relevant. So we say when is 1. At that time the keyboard is disabled, that means we have the register already in data register. But when it's red, the KBSR 50 is set to 0 and we can enter the other character. That means we can press another button to enter the ASCII character to our KBDR. Over here we have the flowchart. We have the basic input routine and we have polling mechanism to check if we have the new character from our KBDR. And this is the small section for the program for checking if we have the new character, and if yes, we go out. First tension. Over here, we declare two memory locations for our KBSR and KBDR at their addresses at E00 and FEO2. Of course, we use decimal system for these addresses. We use PTR, that means pointer. Over here we have a label point. Okay, label point to say now BRGP, that means you prime if 0 are positive. Extension, because once we get the status from our status register, that means we go to the location at the address FE and we put it to R1. Over here, that a label. So if you want to go to this location, and we assign it to register R1 with you LDI. Do you remember LDI? So what is it? Class, what is it? LDI, that means load indirect. You remember? Load indirect. And when we load it, that means you're going to get the relevant and we assign it to R1. At that time, we want to check if it's 1 or not. And if it's 1, that means the value in R1 is negative. Okay, but when it isn't negative, that means we don't have the new character. So we go to pawn. We go to pawn over here. But when it's negative, that means the bit 15 of stated register is 1. At that time, we go out. You know when it's 1. You know when it's 1. Okay, when it's 1. That means we have a character. Okay, we have a character. And the keyboard is disabled. Okay, at that time when we have 1, at that time the value in R1 is negative, so we go out. Over here when we go out, we have a character in R0. Over here, R0. That means at that time we have R0. Okay, you want to assign it to R0. Okay, you want to assign it to R0. That means you want to read it. You want to read the value from KBDR. Because over here we say now KBDR now is storing the ASCII character. So if you want to read it out, so we assign it to R0. So this session is clearer for you to understand, okay? So this is how top 20 works. Okay, so over here in fact the same. Okay, You see, when we go out, okay, this is the drop 20. When we go out, we read the value from KBDR and we assign it to R0. Okay, and we go to the next task over here. And this is the limitation for memory map input like keyboard and extension. In fact, for input devices, keyboard, we have two device register, KBSR and KBDR. And from our program, if you want to check the value, so that means you want to check. So over here, extension, you want to check if the value, the limit of the register, that means you want to check the value, if it's positive, negative, okay? You remember when the relative one, so it becomes negative, okay? So over here, we check it, okay? But the extension is also a register from the memory, okay? And if you want to check it, so you have to get its address, okay? And we use address control logic to control. Address control logic determines if the MDR is loaded from memory, okay, from memory over here, or from KBSR or KBR. Okay. For example, for the first, if you want to read the value from KBSR and assign it to R1, at that time, we have to go to the memory, okay? And over here we have to sitting bit. We go to the memory, the first, because we use LDR. The second, we say now you want to read out the value from KBSR in the memory. So we say we want to read it out and to put it to the register R1. Okay? And for the second KBDR, the same when we go out over here. Do you know when we go out at that time, the value in KBSR is negative. So when we go out, okay, when we go out, we have to decrease from KBDR, I mean the value, in fact. Firstly, we have its addresses. And the second, we have its value. And we put it back to the register R0 over here. And when we go to output to monitor, at that time, we study the mechanism how to display a register in DDR, DSR, and we displays. That means how to output the character in DDR to screen. And over here, we have to register for our output device's screen. And we have ready bit for the bit 15 over here. So we say we have DSR15. And you know, when model is ready to display another character, that means it's ready for its function. DSR15 is 1. At that time, DDR is ready for receiving the new character. Okay? So at that time we say it's ready. The ready in DSR is ready. But when the character is written to the display data register at that time, the relative is 0 to say now DDR is not ready. Okay, so over here we have the basic output routine. Okay, so over here, over here we have the same thing. We check the ready is ready. Okay, the ready is okay. Yes, that means the screen ready. No, we say no. The screen ready or not, that depends. Okay, all the DSR, that means are 1 when it's negative, so we go out. Okay, let me go out. At that time we can write a new character. Okay, but no, that means at that time screen is not ready, so we couldn't write the new character. We write the new character, that means we could or we can't display the new character to screen to our monitor. So over here we have pawn 2. Okay, and over here we check the relative. Over here now we use LDI2. That means you want to read the data, the value from DSR, the means data register. We want to read the data from DSR and we assign it to R1. I will check it if it's negative. Okay, yes. Okay, over here, in fact, extension, okay, yes, we go out, okay, but over here we say yes, we go to pawn, okay. Extension where we say yes, we go out, okay. Over here now we assign this, and if the ready is 1, that means the screen ready is first to receive the order. Okay, so at that time we go out. But when is 0 or positive, that means not ready, so we go to pawn. Okay, we go to pawn to do this. Okay, but when we go out, that means yes, over here in case we say no. Okay, that means we go out. At that time the value in R1 is negative. Okay, is negative, that means we go out. That means at that time the screen is ready first. So at that time we want at that time when we go out, so what do you want to do, class? What do you want to do? Because when we go out, the screen is ready for us to receive the new character. Okay, so over here, for example, we have the new character in R0. Because we just over here we just had a new character from the above. For example, over here we have the basic input routine. So in R0 we have a new character and you want to display, for example. Okay, so over here when we go out, we say okay, now you want to display the value, the character in R0, so we use this function TI. Because you want to assign the value, that means the character from R0 to DDR. Okay, to DDR over here, DDR. That means you want to assign the character, that means you want to display it. So we have to assign it to the location at the address FE06. Okay, let's transfer to this function. And over here maybe you see it's clearer. Okay, and when we go out, the relative is 1. Okay, we go out. That means the screen is ready for us to display the new character. So at that time we can display, of course, base tension. Over here we had already, okay, we had new character already over here as a row, and you want to display it. So if you want to display, let me, for example, 1221H, and you want to display, so we use STI, okay, from 0 to DDR with this. And then we go to the next task.